All right, so today we're talking about the never type. If you're not familiar with my nightly night series, it's when I talk about a random nightly feature in Rust. So something that isn't available on stable yet, but might become available someday if it ever stabilizes. And generally, I like to do these just to, kind of talk a little bit about what these features are, why they're useful, and what's blocking them from being stabilized, and kind of just raise awareness about the feature. And if it's something that interests you and you want to see it get stabilized, and maybe the project is, or the language is open source, so you can always you know try and pitch in if you want, if something interests you. And yeah, so let's dive right into things. So our topics for today are, well, what is the never type? Why is it useful? And why is it unstable? And that's pretty much how most of these go. So let's start with what never actually is. And if you read the official documentation for the never type, you'll see that they always say that it's equivalent to an enum with no variants. So it's essentially an empty type or an uninhabited type. If you're used to how a lot of type theorists will talk about this sort of stuff. An uninhabited type has no members, it has no values, so you can never construct a value of that type. So in this case, you can't construct a value of the never type. That is something that is or should be impossible. In Rust, the never type is written out as this bang or exclamation point. I'll talk a little bit more about that notation because there can be a little bit of confusion about that. And one thing that the never type isn't is the bottom type that used to exist in Rust a long time ago. So if you see anyone talking about the bottom type, just understand that that's something that has been removed from Rust. It no longer exists. You don't have to worry about it. If you want to know what the bottom type was, essentially it was something similar to the never type, except it was a subtype of every other type in Rust. And that caused a lot of issues because um, you'd have container types like a vector of the bottom type, and that wouldn't be a subtype of a vector of any other type. So it basically added a lot of complexity to the language, and so they decided to remove it. And so, as far as I know, the only form of subtyping that's still left in Rust is in lifetimes. For those who aren't familiar with type theory, or maybe haven't worked with types before, maybe you're coming from like a dynamically typed language. I just want to quickly go over how Rust programmers tend to think about types, and here's like a nice visualization that I like to use. So today we're going to be doing a little bit of counting with types. So first of all, we got to start with 0. So this is the never type, bang. It's the star of the show today. And as you can see here, if we try to think of types as sets, then this empty circle here is an empty set. And so it has 0 members inside of it. And if we look here to our unit type, if you're not familiar with the unit type in Rust, it's basically like void in other languages. It's a little bit different, hence why they call it unit, because it actually has a constructible value, which is this empty tuple. But essentially, it just has this one value in it and nothing else. Then we get to a more familiar territory with the Boolean type, which has 2 values, true or false. Right? A Boolean can either be true or it can be false. So as you can see, we're just increasing the number or the cardinality of each set by 1 as we kind of go up here. And that's kind of an important thing to think about when you're reasoning with types is how many values are there in each set, because we like to think about our code in terms of how many valid states can be represented. And we like to try to we at compile time we want to make sure that invalid states can't be represented, and so the more precision we have with our types, the easier it is to control how many invalid states can be constructed. So here we have a type with 3 values, and this is actually the option wrapper. The option wrapper type is basically Rust's way of handling nulls. So other languages might use, nil or null. Rust has this option type wrapper, so it handles it at the type level. And what's nice about that is it makes null safety the default, and you have to opt out of it rather than it being like, say, Java, where all reference types are nullable by default, and if you want to be safe from null pointer exceptions, you kind of have to opt into that safety. And here I have option taking a Boolean as its type argument. It can take any type here. It doesn't have to be Boolean, but because the option type just adds this none case, which is essentially the equivalent to null. It just adds +1 value to whatever type that you pass in here. So this is kind of interesting because the way that option is represented in Rust is as an enum, and you might see enums in Rust referred to as like algebraic data types or sum types, SUM, as in like addition, and that's because enums basically, if you have an enum with payloads and each payload has a different type, the total number of states that you'll be able to represent with that enum is actually the addition of those different payload types. So yeah, this is how we get 3. We take Boolean, which is 2. We add +1 with option with this none, and we get 3. And here we have a tuple. Tuples are sometimes referred to as a product type. Same with structs, and product in this case meaning like multiplication. And you can kind of see we have 4 possible values here. We have true, 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 false, false, true, and false, false. And that's because we're taking 2, right? Boolean is 2, and multiplying it by another Boolean 2, and we get 4. So you can kind of think of types in this very mathematical way, and it's just a nice way of reasoning about how many valid states you have for a particular type, and that's why stuff like never and unit can be useful, is because sometimes you want to just add 1 instead of adding 2, and so you can just throw in like unit, or it depends on the type. Like it'll become more apparent as we get into other use cases later. So here are some properties of empty types. Like I said, you can't construct a value of an empty type, so they don't exist at runtime. So there is no cost to using an empty type. It doesn't impact performance. Code that handles empty types cannot execute. So, for instance, if you have like a panic in your code, then a panic will the return type of a panic expression is never. So essentially, any code afterwards can't execute, and the compiler can see that. So this is just kind of useful for detecting dead code. This one's kind of interesting. They represent the return type of functions that don't execute. So I mentioned panic already as being expression that can't execute. Standard process exit is in a similar boat. It exits out of the function without returning a value. But I thought it was kind of interesting that they also mentioned break, continue, and return. And at first, I was a little bit confused by this because I was like, doesn't return literally return a value? But the way that you have to reason about this is that stuff like return, it stops evaluation of the current function and exits early. So any code that comes after the return can't execute, right? So in the case of return, it does actually make sense that the return expression itself um, returns an empty type. So yeah, that was something that kind of surprised me when I was looking into this, but in retrospect, it does actually make sense. And the last property that I want to cover is how empty types can be converted to any other type. And we'll see that this can actually be pretty useful when you're doing error handling. So I've got a couple of other notes here before we really dive into the whys of the never type. And the first point I want to make is about divergent functions. So in Rust on stable, currently, you might actually have seen this before if you've read Rust by example, but you can actually use this bang in return position for regular functions. And that's actually something completely stable. You don't need nightly for this. In fact, if I just comment out this code and we build this, you'll see that there's no compilation errors here at all. So this is a feature called diverging functions in Rust. So essentially, if you have a standalone function like this and you make the return type just this bang, you can indicate the type, or you can indicate that a function is divergent, and essentially that just means that it doesn't return anything. And you can see here we have this panic here, and then we have this print line, but we know this print line will never be reached, right? Unreachable statement. So that makes sense. So what does this never type feature actually do? Well, we'll see here that this code, no, here, actually, let me just comment that back out. If we try to compile this, then it'll say that the never type is experimental, and we now actually have a compilation error. And that's because while you can use bang on its own as a return type for a function, you can't treat bang as a type in general. So essentially what this flag does is it promotes this bang notation to actually be a proper type. So if we re-add that there, then we can see that we don't get the compilation error anymore. And we can actually safely pass in this this never type here as a type argument to result. So yeah, it doesn't just add this bang notation that already exists. It just allows you to use it as an actual type. All right. And another note that I wanted to make is that when you're looking at documentation around the never type or empty types in Rust, something that you might come across is this thing called infallible. So it turns out that Rust already sort of has kind of a canonical empty type, but the way that it's defined right now is just as an empty enum in the standard convert module. So it's just part of the standard library. It can be used as an error type for results when you want to indicate that no error can happen. So basically, it's useful in cases where you have like maybe like a trait or like an interface that returns a result, and in some cases there can be errors, in other cases there can't be errors, and so for some implementations you will want to actually return an error, and in other cases you want to just specify that the error type is never. Essentially, infallible will be turned into an alias for never eventually, and it will be deprecated and removed. So yeah, don't worry too much about infallible, at least in the future once never gets stabilized. if it gets stabilized, I should say. But if you want to read more about infallible, you can read about it there. And I will also be covering why they're deprecating this, like some of the differences between just defining an empty enum versus using this actual like built-in primitive never type. So let's get into reasons for why the never type is useful. So yeah, the first reason here is something I've already kind of talked about. You can use it with results to indicate that no error can occur. Why that's useful is because now you can avoid usages of unreachable or other kinds of like panics that you might put in place to indicate like, hey, if this code executes, there's a bug here. Please contact the developers, kind of thing, right? Um, so those kinds of cases can often mask bugs, and it'd be nice if we could just completely avoid those kinds of cases. With the never type, um, because the never type can be converted to any other type. What's nice about that is when we get an error case for a result that has never as the error type, we can just pattern match on the result, and then we can extract the error and then return the error as is, because the error is never and will be converted to whatever the output type is. So it sort of just kind of flows naturally, and you don't really have to worry about like handling that case. What should you do in that case? Um, the problem kind of just solves itself. Um, Another thing that you can do with the never type is implement any trait for the never type. And at first, this might not it might not be very obvious why this is useful. So I kind of threw together a little playground to show off why this is helpful. So here we have a trait foo, but it could be any trait, and it just has a single method baz that takes self and returns a u32. But you could imagine this as being any type signature, right? It could return like any type. It could return like your database connection or whatever. And something that's nice about the never type is you can implement any trait for it, and you don't have to produce a value for your implementations. So like, for example, if we were to implement foo for unit instead, right? We would then be forced to actually materialize a U32 for this method. And if this was like a database connection, then we'd be forced to actually materialize like a database connection for this. But with never, you don't actually have to do that. You can just match on self, right? Self is the never type. And so therefore, you can just have an empty match, and the compiler will completely and happily accept this. And that's okay. As for why that's useful, so we have down here a function called bar. You can kind of imagine this is a fairly common case, even though these are kind of dummy types. But like here we are taking an optional argument where that argument type needs to implement some trait. In this case, it's our foo trait. And what might happen is you might want to pass in none down here to bar. And what's interesting about this is if we try to compile this code just by passing in none like this, it'll actually ask you for a type annotation. And this can actually be kind of tricky to deal with if you don't have the never type, because obviously whatever type you specify here has to implement foo, right? Well, we don't really care what this type is because we're just passing in none, but it has to be something that can implement foo. And an easy choice is, to use never, because never can always implement foo. Or sorry, yeah, you can always implement foo for never. This wouldn't be the case for unit, right? Unit might be a little bit harder because the implementation for unit would actually have to return a value for each of these methods of the proper type. Whereas with never, you don't have to worry about that. So it's actually way easier to just be like, all right, put never here. and move on with your day. So yeah, that's one of the main reasons why never is really useful for traits. I think I heard maybe there was a question in the chat. Someone say something? Is
Yeah.
option never a zero-sized type? Uh, that's a good question. I don't know off the top of my head. I would
It seems
guess.
like it would be, right? Because you have like the sum type thing, but it's the sum of like 0 plus
And
1
one.
none.
Yeah, like unit is also a zero size type because it doesn't take up a bit in memory, right? You have to have at least two states before you need like a bit to represent that data. So if you have only one state, then I imagine that it would be a zero size type as well. Uh, I'm not sure how smart the compiler is about that, to be honest. You could probably check that using size of. So there's like a size of function in the standard library that you can use to check the size of types to see how many bytes they take up in memory. And yeah, that wouldn't be too hard to verify. Actually, we can do that exercise afterwards. I just want to get through the rest of the talk first, but yeah, that might be something to try out. Um, yeah, the last thing I wanted to mention is that the never type is useful for dead code detection. I've kind of talked about this before, but whenever you have like a panic or any other expression like break or return that has this never type, then the Rust compiler can see that anything afterwards is dead code. Therefore, you can actually report that code will never be run. So yeah. So here's why we don't want to just use empty enums for everything. So the first point that the Rust developers make is that it's simpler to have a standard empty type for all Rust code, and this makes sense, right? Because otherwise, libraries could each define their own empty types that they're working with, and then they'd all expose their own empty types. And then if you're writing, application logic that relies on these APIs, then you're gonna have to import all these different empty types if you want to work with each of these libraries, and it's just a bunch of extra busy work. It's kind of messy. Um, they also mentioned that improved dead code detection requires having some kind of canonical empty type. And last but not least, uh, having a canonical empty type can actually simplify code. And they give an example here. This is a really useful document to look at, by the way, if you're interested in looking at the never type or reading about it. This is a never type initiative. They have an example here where they actually define an empty never type. And this is code that can be run today without using any nightly features. And they compare it against this code down here, which is the equivalent code after the never type gets stabilized. So you can see that this code has a bunch of extra boilerplate with this wrap exit and diverge from never. You can see that they're used here, whereas here they don't have to do the wrap exit. They don't have to return a empty enum type here. Like here, they actually explicitly return their user-defined never type. Here, they just use the built-in primitive. And for divergence, they don't have to wrap this value with anything. Here, they have to wrap this in diverge from never. So it simplifies code. It removes some extra boilerplate. Obviously, this isn't stuff that you really want to have to add in your code. So yeah, it's just nice for making things a little bit simpler. And yeah, I also wanted to quickly cover comparison with other languages, because obviously other languages have their own kind of solutions for this. So why does Rust decide to use a type for this? And it's generally a lot nicer in terms of composability. It's similar to Haskell's either. Rust's result is similar to Haskell's either, and Haskell also has its own like empty type. So it's a much more composable solution than say C++'s no return attribute. And it's like if you want to say that your function doesn't return an error when you're implementing some API, right? You can easily just specify it right in the type. It's just another part of the language. You just put in this never type for the error type, and now you don't really have to worry about the error case anymore. So yeah, just a very quick note about why Rust chose to go down this way. A lot of Rust decisions are inspired by Haskell, which is why it often chooses to go with the very type theoretic approach to things. As for why the never type is unstable, as we can see from the tracking issue here, there's some regressions. So they actually did try to stabilize this at one point, and then they realized that it was actually kind of problematic because type inference was falling back to unit type in some cases, and that was kind of bad. And to actually, illustrate that point, I actually threw together a code sample from the RFC in a playground that shows exactly what they mean. So here we have a struct E. It's an empty struct, so you can just kind of create it as is. And they implement the from trait for E, but they implement it using never as the type parameter. So this is a function that converts from never to E, which means, as usual, this is a very trivial thing to do. Here they actually decide to construct the E directly, but you could just do like the if they actually explicitly took in this argument, they could have done the empty match as well that I showed off earlier. Here we have a function foo, which takes this variable never, which is of type never. And so in this first case, things seem fine, right? We say that E is this from never. And so when we call from on never, we should get an E out of that. And that's okay. But here's where things kind of fall apart. So you see that if we don't explicitly specify never here as the type argument for from, it'll say that the trait bound is not satisfied, and it'll actually replace this wildcard with unit. And this is kind of unexpected. I also show off what this syntax would look like without these extra adornments here. So this is what you might typically see in most code. Is just this E from, sort of like when you're doing like a string from, you give like a string slice kind of thing. Like this is the regular case, and this is just shorthand for this case. So you can imagine like you're looking at code like this, and you're like, okay, well, is there an implementation of from for E that takes never? Yes, there is. Okay, well, this code should just work. And then you compile your code, and that's just like, what? Why is there unit here? Well, this is clearly a bug, right? So that's the reason why this feature hasn't been stabilized yet. There are some issues with type inference. So yeah, that's pretty much my entire talk. I've kind of listed out a bunch of references here that I used in my talk. But otherwise, yeah, I think what I kind of want to do right now is dig into this size of and see what that's see what that's about. I actually forget. Is it like mem size of? Yeah, standard mem size of. Yeah, this lets you see the size of a type in bytes. So we're just gonna do that real quick here.
Oh, it's done. See the link.
Oh, someone's already done it?
Yeah.
Oh, okay. Oh wait, yeah, this is.
Yeah, and it is a zero size type.
It is a zero size type. Okay. Yeah. All right. Well, here's the proof as well. It is a zero size type if you check option never. Yeah, that's pretty much it for my talk. If anyone has any questions, feel free to ask.
I got one more question.
Yeah, go ahead.
First of all, that's really cool about the size. Like, it makes sense that the compiler, it like if a never type is sitting in one of the enum variants, that the compiler could just look at that and be like, oh, well, that one can't ever happen. But then it's cool that like when the number of enum variants drops down to 1, the compiler can then like remove the discriminant and like everything and just like fold it down into nothing. I think that's pretty cool. And that like it goes to show another powerful thing about this is like in generic code, if you plumb like a never through a bunch of stuff, it'll all like optimize really well if it can. Anyway, yeah. So my question is about the type coercion stuff. So you mentioned at the beginning that never is not the bottom type, so it's not a subtype of everything. But I noticed that you did mention that it is you can coerce it into everything, and of course that's important for like having an if else where one of the branches like returns and the other one evaluates to a value. But I'm just curious if you have any comments on like the distinction between being a subtype versus being like able to be coerced to everything, because it seems very similar to me, but I imagine there's some like subtle differences.
Yeah, it's more of like it's more like I think I don't know the exact details of how they implemented it. I didn't dig that deep into this, but it's more like they probably implemented like special casing to allow you to coerce never to any other type rather than it actually being a proper subtype. The thing about the subtyping for the bottom type before was that they had cases like this where they're like, is this a subtype of this? And then you start to get into stuff like covariant, contravariant, invariant functors, right? It kind of gets messy. Um, I think in general, it's not easy for the compiler to, or it's not a tractable problem to determine statically if a type, uh, or if a type parameter is in like a covariant position or it's invariant or contravariant, right? In Scala, the way they solved it was the user has to specify that. They have to put like a little plus in front to indicate this type argument is covariant or minus for contravariance, and nothing for invariance. I think there's also like bivariance too. It's kind of complicated, and yeah, I think that's probably the reason why they decided to scrap that. And also, in general, Rust doesn't really have subtyping at all. At least when it comes to regular types. When it comes to lifetimes, yes. If you want to say like this lifetime, outlives this other lifetime or whatever, then you have, or lives at least as long as this other lifetime, then you have the notation for that, and they do have rules around like variances for lifetimes. You can read about that. I think it might be in the Rustonomicon, if I remember correctly, where they talk about all the rules for that. Pretty complex stuff that most developers don't want to have to worry about or think about. So I think that's the main reason why they decided to scrap having an actual bottom type for Rust. But
Yeah, that's helpful. I appreciate that. It's interesting because like when you're passing around a type that can like coerce into anything, it certainly feels like you're working with the bottom type because just like syntactically, it sort of seems like it
yeah,
anything.
it
But
feels like the bottom type, and that's what they were going for. They wanted it to feel like you're working with the bottom type, but it isn't like actually the bottom type.
right, so they get to sidestep all the variance stuff because there's like sort of this very thin line of coercion, which isn't very common in Rust also, which like also adds to the illusion that this thing actually is a bottom type, but it's not.
Yeah. Also, I can also show off like I talked a little bit about the match. Maybe we shouldn't call this never. I'll just call it res. But this is what I meant when the problem kind of solves itself. You can have the OK here. It takes whatever our result type is, and we can do whatever you want with the results, right? You can print it, whatever. And in the error case, it doesn't really matter what the error is because we know that the error is never. So because it can be coarse any other type, you can just return it that. So that's what I mean by you don't need to, handle like unreachable and stuff like that. I feel like I may have glossed over that a little too quickly.
It'd be nice if you didn't even have to put that.
That's true. Yes, but it would be nice if you didn't have to do that.
Because then if you change it to something that can fail, like you would get an error right there that you're not handling it. And that'd be nice.
Yeah. I mean, Rust type system is, it's pretty good, but it definitely leaves room for improvement. There's definitely things that I wish were in Rust type system that it doesn't have, especially coming from languages with dependent types like Idris or Agda. There's definitely some things that I'm kind of like, oh, it would be nice if we had this in Rust, but I also understand that extra complexity adds to the type system, and trying to maintain zero cost abstractions at the same time. It's a very, very difficult thing to do, especially when you want your language to be sound. Like that's one of the big selling points of the language is soundness. You don't get those kinds of memory corruption bugs that lead to like serious security vulnerabilities. That's one of the guarantees of safe Rust. So
Another practical use that I had to step off for a few moments. So it may have been that Jonathan already mentioned it, but what I use when you suddenly have some big code base that doesn't compile, or if your code if you use some crazy generics or something crazy, and suddenly you hit the ICE internal compiler error, what you then you want to minimize it so you get an example to report, and also maybe so you figure out what's causing it, and you can use the never type to eliminate expressions when you are assigning to variables and also when you are returning. So instead of let mute my variable equals some crazy expression, I assign let that variable equals loop with no body, which never finishes, and therefore that's the type of it is never type, and it can be assigned to any variable, and that way you can minimize code very quickly.
right, yeah, that's also a really good use case for never. Touching on infinite loops, and like infinite recursion, you know, and the type of that, or what values those return. Like there are some things that I kind of glossed over, especially when it comes to like infinite recursion, because you know in Haskell they have like a bottom value for, you know, any type. I don't know if Rust explicitly defines anything like that. I'm not too clear on the details there, but yeah, in general, um, when we think of types as sets, that's mostly for like pedagogical reasons. And once you start to get into like actual proper proof assistance and stuff like that, those kinds of you know, infinite loops and stuff like that can cause paradoxes in proof assistance. So yeah, eventually you get into stuff like homotopy type theory, and then they start saying, oh no, types are not sets. So yeah, things kind of get a little bit wonky. I didn't want to get too into the weeds here though, so we're just gonna say that types are sets, at least for us, and that's the way that the developers want you to reason about types as well. It works for the most part. I've got a couple of comments here in the chat. But print line, form size of, so that's an array of size 10,000 of nevers. Yeah, 10,000 nevers. Yeah, the size of that is still 0. Yep. There's also standard any, which is implemented by most types. Yeah, that's Rust's way of sort of doing dynamically typed stuff. If you don't want to do the match, just using question mark might be more ergonomic. Yeah, I guess. I didn't really think about that. Well, question mark well, any function that uses question mark has to itself return um, the monad, right? Or the, I guess in this case it would be result. You need to return a result from that function. Whereas like in my playground example, you're not returning a result from that match. This is not the right playground. So if you wanted to use a question mark here, you'd have to also like make sure that you're returning a result here as well. That's just a property of that sort of monadic notation. Unwrap if it's infallible. Yeah. Yeah, take care, Peter. Any other questions or comments before we move on? Yeah, I wasn't returning a result. Going once. Going twice. Okay. With that, I'm just gonna dive in to the next topic. So, like I said, the office, my office, the improving office, is going to be reopening soon. So, um, I know I've been saying this for a while because they've been saying this for a while. Like I don't really have any control over this. Like the current situation is basically they push updates to me, and I have basically no say in like whether this gets whether the office opens faster or not. That's just kind of the way that it is. Um, so they are saying again that the office is going to open soon. We'll see about that. But this time, I feel fairly confident that we're actually going to open this time. I know I've said this like multiple times last year, and I'm really sorry if it feels like I'm just like stalling or something. No, it really is just we are waiting on like contractors, and we're waiting on permits from the city, inspection. All that stuff has finally been dealt with, and I was just told today that starting I think on Monday next week, um, people will be allowed in the office, but not too many people. They're still working out issues with the internet right now. And that's obviously kind of a showstopper for us, especially because I want to continue to run the events hybrid, so that we have people from across the globe able to still join. Especially when we have one of our co-organizers here from Toronto. He can't exactly make it here, and I want to allow Chester to still be able to join us. So yeah, not having internet or having like spotty internet is kind of out of the question. So uh, right now, no, we're not going to be able to have people in, but we are. I can say pretty confidently that it's pretty imminent. If they have um, facilities opening up and they're going to allow people to start working back in the office again, even if it isn't just in small groups, um, we will have an office space again, and we will finally be able to have our first in-person meetup since I think the beginning of 2020, maybe even the end of 2019. It's been a really long time since we've had in-person meetups. So yeah, so if you're looking forward to in-person meetups, yeah, they will be happening again. Just I need to sort out a bunch of details. I will post an announcement once um, once the office space is available. Um, you'll probably notice that I haven't been posting any announcements lately, not even reminders for the meetups. That's mostly just because at some point over the last month or so, uh, Meetup for some reason decided to stop working. And anytime I try to send an announcement or a message to the group, uh, yeah, it just swallows my messages. I don't know why that's happening. I haven't done anything different to send the messages. It's pretty annoying. I will be contacting support to try and get that all sorted out. I thought that was just maybe a one-off thing, and they'd fix it by this month, but evidently they haven't. So yeah, I need to figure out what to do about that. Um, and obviously, I need to actually secure the venue, make sure that uh, we have all the facilities we need to run a hybrid meetup. So there's still a bit of work to be done on my side before we can have in-person meetups again. But just know that it'll be happening soon. I am putting in the effort to make sure that this does happen. And yeah, if you're looking forward to that, then hopefully we'll have something ready for you within the next couple of months. They said there'd be an office reopening party in either March or April. So I'd say most likely the latest would be sometime in April. We'll be able to have meetups again in person. But yeah, I think it might be a little bit sooner than that. It just kind of depends on how things go with the internet issues. Yeah, so with that, I don't really have anything else to say. If you want to discuss whatever, feel free to jump in and talk about your projects, or if you have any other questions, you can do that. I see that we've already got quite a bit of discussion in the chat. I wonder if we can unwrap or never. It looks like that's not working. Well, the thing about unwrap or with never like that is, remember, never is a type, right? It's expecting an expression. You can't just put the bang in the unwrap or like that, because types are not expressions in Rust. So yeah, that one doesn't compile.
I think the intention was kind of like how the unit type is both a type and an expression. So you construct the never.
The unit type isn't technically an expression. I mean, it's just the name of the unit type happens to align with the single value that's inside the unit type. Because there are other languages like Scala that have a unit type where it's actually spelled out UNIT, and then the value is the empty tuple. But yeah, never isn't never doesn't have any values, so you can't use it in the position of an expression. Anything else? Nobody wants to talk about anything?
Well, quick update on the log view I was doing. I think I spoke about the last meetup.
Yeah, how's that going?
It's not done, but I've stopped working on it. It's working enough that I'm happy with it where it is.
Cool.
So it works now.
Did you want to do a talk on that, or I think that
I
was
feel like it doesn't have much material. But then probably interesting bit would be showing how easy it is to use the tables in eGUI. But I would probably hold off on that until I try out a couple more things because I want to try out putting different types of controls inside of the table instead of just labels, which is what I needed for this project.
Yeah, don't feel pressured or anything to.
No, it's fine. I mean, I will probably do a talk on because I have lots of projects going on that I think are interesting. It's just that they're all going on and they're very busy, so I don't have time to prepare a talk on them. But yeah, I think either that one or probably the same one I did the presentation on. It's taken on a lot more stuff now. I think it's actually very interesting to do an update on that one.
Okay, cool. Yeah, if you want to, feel free to, yeah, go ahead and do that.
Yeah, but
Only
probably not for a few months.
Yeah.
Yeah.
I was thinking next time, I might do another talk, maybe on procedural macros, since I've played with them quite a bit now, and yeah, I don't know. It might be more of a talk of like what not to do with procedural macros and how to try and use them.
How not to fall over.
My experiments ended in failure, but
those are still results.
It might be interesting anyway.
Yeah, those are still results, right? Don't do this. I fell this way. Try something else.
Yeah. Yeah, it was a big reason why I ended up abandoning the project that I was working on. Sadly, it was very experimental, to be fair. And when it comes to working with experimental stuff, especially when you're hacking onto the Rust type system, it's like you kind of have to expect that not everything is going to work, and there's probably a high chance of failure. But I was so close that I was like, oh my god, this is gonna be pretty cool if this works. But then, yeah, things kind of fell apart, especially when it came to procedural macros. So I don't know. I might talk a little bit about that next time, but that's only if nobody else has anything else they want to talk about. And then I think my plan for the month after is just to have another free discussion. Give people a chance to come with their own questions or discuss whatever they want. Have a more chill, more relaxed session. So yeah,
I like what you did tonight. I think too, like for some of us that are much less informed on the language and just trying to get through the Rust book, like just to have someone who has done more Rust programming talk about a basic idiom of the language. Like tonight, it was the use of never. Another one could be like lifetimes, or I don't know, and just to get a basic, I think it adds value for people that are trying to learn the language, is just to go over it and to have people that have used the language more, like pipe in and say, you know, yeah, here's how I use that feature or not. I don't know. I think it's cool to have that, even if it's not long, as opposed to just a totally wide open thing. And that's a suggestion by someone who is not at all prepared to give one of these descriptions. But if someone else, like the thing you did tonight was good, that's what I'm saying. And I think it's even if it's not the full meeting, just having it maybe as a starting point is good for us people that are trying to learn the language.
All right, yeah, I'll take that feedback into consideration. And yeah, that's kind of the point. I didn't intend for this talk to be particularly long. Like originally when I drew up the slides for this, it was only like 10 slides long, and then I kind of stumbled upon a few other things. I was just kind of like, oh, I kind of want to throw these in too because it was kind of interesting, like infallible and other weird like historical cases that came up. But yeah, the general goal, at least with like these nightly nights, is just to raise awareness about a feature, show off how it's used, and again, show people why something like that would be useful, and get people interested in talking about these sorts of things, because I find a lot of nightly features that are actually pretty interesting, and a lot of people just don't really have much awareness of them. There's a pretty big list of nightly features that either will never get stabilized probably, or are like imminently going to be stabilized, and so there's genuine like awesome use cases for them. But yeah, I don't tend to like to run just like free discussions most of the time. I tend to find that a lot of people drop out of those. They're not too interested in just having like a free discussion, but I do occasionally get requests from people saying, hey, I don't like that all you're doing is presentations, all you're doing is talks. I feel like we don't have enough time to just like discuss Rust or discuss other things going on. And it would be nice to have time to do that, or like ask whatever other questions and not have to like sit through an entire separate discussion or presentation beforehand. It's hard to find a balance that satisfies everybody. So what I'm trying to do is maybe like every 3 months or so we'll have like a free discussion for people who are interested, and most of the time we'll just be doing talks on various things in Rust. We used to have more like active participants from like AWS and like Huawei, Google, people who would come in and actually like do talks about like how they've been using Rust in industry. I haven't had too many volunteers come by in the last like year who are interested in doing talks like that. So that's why we haven't had too many of those recently. I have a project that I'm working on in industry that does use Rust, but I'm not sure if I can talk about it because of NDAs. So it's kind of giving people the kind of content that they want at the meetups is not exactly easy, and it also largely depends on what kind of people are interested in coming and doing talks, which is why I encourage you all, if you have anything interesting to talk about, please contact me, contact Chester, and we'll try and get you scheduled in. Because otherwise, we're just kind of flying by the seat of our pants, and talking about whatever is interesting to us, or at least I'm talking about whatever's interesting to me. All right, see you, Jason. Yeah, if there's any, if there aren't any other questions or comments or feedback, then
I would just want to probably because it's made my life so much better. I wanted to share the Atwin.
I think may have gotten interrupted.
Yeah, sorry about that. I got kind of interrupted. Saying that I've been using Atwin for my shell history, and it's really been quite interesting because I now save comments with my shell history so that I can find the commands again. I'm not sure if you guys are familiar with Atwin. It's a shell history tool, I guess.
Did you want to share that, or?
Sure, yeah, I can drop a link. Let me get it 1 second. Yeah, that's it. I keep on forgetting it doesn't run on Windows right now, but it runs, but Windows doesn't have it easier to plug into shell history. But yeah, it can. It's just that would need to be some tweaks to get to the Windows.
Yeah, I've run into a couple of problems when it comes to Windows support in our own Rust project that we've been working on. I think one of the Tokyo libraries doesn't support Unix sockets on Windows or something like that. And, yeah, it's kind of annoying. I think Ivan also posted another link here for people looking to contribute to some real projects. He posted one of his. It's an unlicensed decentralized identifier intended for personal use. So yeah, there's a link to that. I think these links will be posted to Discord, if I'm not mistaken, right, Chester?
Yeah, I'm posting them.
All right, cool. Yeah, so if you're worried about like missing out on any of the links, they will be posted to the Discord. Speaking of which, yeah,
I'm kind of curating the links though. I'm copying the links, but like just the chat, I'm not copying all the chat. Just the
no, that's fine. Yeah, you don't have to copy all the chat. I don't think we need to save all the chat. But yeah, if you haven't joined the Discord yet for whatever reason and you're interested in joining our community Discord just for the Vancouver Rust meetups, then yeah, we have a link to that. Right link. Here we go. Okay, Chester's got it already. Yeah, you can join us there. Yeah, otherwise, anyone else have anything else they want to talk about real quickly before we end things here? Going once, going twice. Okay. Well, thank you all for coming. I really appreciate you all coming out here tonight, especially, because we still don't have in-person meetups. I know that some people are losing patience with that, but I assure you that it will be happening soon. So, yeah, thank you all. Really appreciate it. Again, means a lot to me that people actually come out here and come to our meetup. These meetups don't happen without people actually coming out here and joining. So, thank you, and yeah, I'll see you next month. Hopefully with another interesting talk.